So today we're going to look at simplifying rational expressions. So a rational expression is a fraction. It's a fraction in which the numerator and the denominator are polynomials. So polynomials is what we've been working on. We added them, we subtracted them, we multiplied, and most recently we've been factoring. So there are 3 steps that we're going to use to simplify rational expressions. So step 1 says that we're going to factor. We're going to factor the numerators, which is the top of your fraction, and the denominator, which is the bottom of your fraction, completely. So that's what we've been working on. Step 2 says we're going to cancel out any common factors located in the numerator and the denominator. So that just means you can cancel the same thing that's on the top and the bottom. And then finally, we'll write our final answer. So let's look at example 1. Example 1 says we want to simplify 2x over 4x squared minus 2x. So our first step was to factor. So we're going to factor the numerator, which is 2x, but there's nothing to factor there. That's only one term, so there's no factoring to be done. And to factor the denominator, which is 4x squared minus 2x. So we have 2 terms here in the denominator, so our first step is always greatest common factor. So the greatest common factor, we're just looking at the denominator here, between 4 and 2 is a 2. And notice they both have the variable x. So we're going to factor out a x. So then to get our insides, we have 2 terms, so 2 blanks. 4 divided by 2 is 2. Subtract your x's. 2x's minus 1x is an x. And then the second term, negative 2 divided by 2 is negative 1. X minus x, that's gone. Okay, so I'm just going to rewrite the problem here a little neater. So on the top we still had 2x. The bottom now is 2x times the quantity of 2x minus 1. Okay, so this is what we're looking at. Then step 2 said that we want to cancel. Cancel anything that's the same in the numerator and denominator. So we have a 2x in the numerator and a 2x in the denominator. So that means we can cancel these out. And then we're just going to write our answer. So in our denominator, we still have a 2x minus 1 left. We don't have anything left in the numerator, so that means we just put a 1. So our final answer is 1 divided by 2x minus 1. Okay, so the next slide says an example of what not to do. What not to do. So if we look at this problem in the box, we have x squared plus 2x plus 1, all divided by x squared plus 3. Now notice this person tried to cancel out this x squared and this x squared. Well, that doesn't work that way. You can't cancel those. You have to factor before you can cancel anything. Because notice you still have this plus 2x plus 1 and this plus 3. So this is an expression. You can't cancel things out of the expression. It has to be factored first. So this answer is not correct. You cannot do that. Example 2, we have 2x plus 1 all divided by 10x squared plus 5x. So step 1 was to factor. So let's factor the numerator, 2x plus 1. So 2 terms, you look for greatest common factor. Greatest common factor between 2 and 1 is just 1. No variables in common, so no greatest common factor other than 1. Second step is difference of squares. Well, that's not a difference, so we can't factor the numerator. So let's see if we can factor the denominator. So the denominator is 10x squared plus 5x. So greatest common factor would be 5. They both have an x. 2 terms, so 2 blanks. 10 divided by 5 is 2. Subtract the x's. 5 divided by 5 would be positive 1. Subtract the x's. So I'm going to rewrite my problem. So we left the top alone. The bottom became 5x times the quantity of 2x plus 1. So step 3 was to cancel anything that you could that's in the denominator and the numerator. So the numerator and the denominator both have this 2x plus 1. So that means those would cancel each other out. The 5x is left in the denominator. Nothing's left in the numerator, so we put a 1. So your final answer is 1 divided by 5x. So example 3, we have a squared minus 49 all divided by a plus 7. So let's start by trying to factor the numerator, the top here, which is a squared minus 49. So we have two terms. So first thing under two terms is greatest common factor, and that one does not have a greatest common factor. So the next thing is difference of squares. So we do have a difference because it's a subtraction problem, and we can take the square roots. So a squared minus 49 factors into a minus 7 and a plus 7 all over. Okay, and then we'll see if we can factor the denominator, a plus 7. So two terms, no greatest common factor, and it's not a difference of squares. So we'll just bring that one straight over, a plus 7. Then we'll see if we can cancel. So we have a plus 7 in the numerator and a plus 7 in the denominator. So that just leaves us with a minus 7. Nothing in the denominator, so our answer is just a minus 7. So example 4, we have a squared plus a minus 12, all divided by a squared plus 2a minus 15. So we'll start in the numerator, a squared plus a minus 12. So three terms, and these are all 1s in front of these a's. So greatest common factor would just be 1. So we'll do brute force. So 1 times negative 12 is negative 12. We need it to multiply together to give us negative 12 and add together to give us positive 1, which is going to be 4 and 3, with the 3 being negative. So our fractions will be 1 over 4 and 1 over negative 3, which we can't reduce. So we'll have an a plus 4 and an a minus 3. So we'll look at the denominator. A squared plus 2a minus 15. That's a 1 in front of the a squared. So greatest common factor is just 1. So we'll have to do brute force again. So negative 15 when we multiply, positive 2 when we add. So that's going to give us 5 and 3, with the 3 being negative. So our fractions would be 1 over 5 and 1 over negative 3. So our denominator then is going to be a plus 5 times a minus 3. And then we'll see if we can cancel. So we have an a minus 3 in the numerator and an a minus 3 in the denominator, which cancels out. So that leaves us with a plus 4 in the numerator and a plus 5 in the denominator, and that is our final answer.